In this video, we talk about defining your own functions. Before you write your own functions, it's helpful to understand that when a function is called by the main program, control is passed from the calling program to the function. The function code executes, and when that process is complete, control is returned to the calling program. We can think of this as program execution taking a bit of a journey from the calling program to the function and back again. While the function that was called is executing, the program that called it does nothing. Its execution is paused until the function completes. And then when the function returns control, the calling program can continue executing at the point just beyond the function call. Control is always passed, but there is also the issue of whether or not information is passed between the calling program and the function. When we consider this aspect of function usage, there are four possibilities for the connection between a function and the program that calls it. In this video, we will work through all four of those. This should give you an understanding of the different ways in which you can write functions to do some of the work required in programs that you develop. Typically, in R programming, you're less likely to see all four of these than you might in other languages, but this will give you a sense of what the possibilities are, which will be useful if you change to other languages in the future. We'll start with the simplest situation, a function that has no parameters, so it receives no information when it is called, and it returns no information. A function like this would be useful if you wanted to create a nice user interface for your program, perhaps by displaying a menu of options for the user. For example, let's consider a function that displays a menu for an inventory maintenance system. We can call that function with a very simple statement that I have here on the left, but we'll see at the end of the code when we go into R. So let's see what happens when we run it. Here's the same program using RStudio as the development environment. I'll go ahead and run it. And we can see that all of the menu options are displayed as a result of the call to the function that was made at line 11. And then we see in the output the OK, which I put in just as a confirmation that the function finished execution, and we reached line 12. Just like when you call a built-in function, execution of the call to this menu function causes control to pass to the function. The function will execute one line at a time. When the end of the function is reached, control goes back to the calling program, which continues executing after the call to menu, printing out OK at the print statement. The next kind of function is one that receives some information, but does not return any information when it finishes executing. This setup is common if we write functions that are used to generate nicely formatted output. For example, if we stick with our inventory example, we might have a function like this, which is designed to provide nice output. When pretty print is called, 3 pieces of information present here in the function call are passed to the 3 parameters in the function definition, giving those parameters values during the function execution. Again, we can see that in R. Here's the pretty print function. It's set up to receive 3 pieces of information: the item name, the quantity, and the price. In the call, we pass values for those 3 parameters. We pass these 3 pieces of information. In the function, I'm using the R paste command, a call to the paste function, to do string concatenation. And when the function runs, we see the printing of the 2 lines of information. So again, control at line 8 is sent to the function along with the 3 pieces of data, the 3 pieces of information. The function executes 1 line at a time using the provided information as necessary, completes its job, and returns control to line 8 where the call was made. Next, we'll define a function that has no parameters, so no data comes in. It receives no information when it is called, but it will return information. You could use a function like this to display a menu, as we did earlier, then get the user's choice and return it to the calling program. Calling this function is a bit different than when we called our original menu function, because now we have to have a way to capture the value returned by the function. We handle that by putting the call to the function on the right-hand side of an assignment. The way to think of this is that the call to user option will then be replaced by the value that is returned from the function. And then that value will be assigned to action on the left of the assignment. And I can verify that it worked by printing out the value of action after the function execution is complete. We'll see this in R. In my user option function, I am using an explicit return statement at the end of the function at line 10. Although in R, it is not necessary to have an explicit return. If I took line 10 away, whatever line 9 computes is what would be returned by the function. Since many of you watching this are new programmers, however, I think it's helpful for you to have the explicit return statement. Now I'm going to execute this. And at line 13, the assignment cannot happen until the call to user option executes and the return value becomes available on the right-hand side of that assignment statement. So I've hit run. We can see in the console window that execution basically paused here at line 9, and the read line is waiting for the user to enter their choice. So I'm going to enter R, type R and hit the return key. Once I do that, line 9, the read line is complete. It assigns whatever I entered to the variable choice, and then that value is returned to the call at line 13. We can think of this right-hand side of the assignment, the call to user option, as being replaced with that character R, which was the returned value, and that value is then assigned to action. And we get confirmation of that when line 14 executes and the user's choice is printed out. Our last category is functions that both receive information and return information. So they have both parameters and a returned value. These are functions that we generally use to do calculations. Information is passed to the function. The function carries out some calculation that is relevant to the problem being solved, and then returns the result. We can see this with a variation on our printing operation. In this case, I've put the printing steps in a main program, but I'm computing the value of the item in this separate value function. The function call has two parameters. So we pass two pieces of information, one for the quantity of an item and one for the price. The function will return the total value of those items. And so we can see that my main program consists of some setup where I assign values for quantity, item, and price. And then I set up my print statements. I set up the information that will be printed by creating the string concatenations. And in this second one, I have the call to value. We can see this a little more easily in R because the way the line wrap is not used here. I did need it on the PowerPoint slide. So we can see here I'm setting up values for quantity, item, and price. I set up the string that will be the first line of output. And when it's time to build the second line, I have the call to value, which will pass the value of quantity, the value of price. Those come to the function. The computation is carried out. The value is returned. It replaces this function call, and there's an actual number that can then be used as part of the output. And so when I run this, I can see that that place where we had the function call was effectively replaced with the result of the multiplication, 18,750. So I want to look at one final example where I have two user-defined functions and one calls the other. The main program starts here at line 13, where I initialize quantity, item, and price, and I make a call to pretty print. So this looks a lot like my original pretty print example. But when I look at this version of pretty print, it's not doing the computation in place, it's calling the value function. So I've written two functions, my pretty print function and the value function, and my pretty print function will call the value function. So the main program sets up the initial values. It makes the call to pretty print, passing three values, which come into pretty print as the item, the quantity, and the price. And then pretty print will call value, passing the quantity and the price. Value will do the computation. It returns to pretty print, which finishes its job and returns control to the main program. And in this case, there is no additional work done by the main program. So this gives you a sense of how you can create the same kind of sequence of function calls and operations that you have when you're using built-in functions in R as well. So that wraps up our tour of the 4 different kinds of function setups you can have when you write your own functions. When you write your own functions, consider the following things. First, what part of the program's job can you compartmentalize into a function? You want to think in particular about operations that need to be done more than one time. Writing that code once, but using it from different parts of the program is helpful for the development of your program. Second, you want to think about whether the function needs to receive any data in order to do its job. If so, exactly what data does it need? And you want to think about whether the calling program needs to receive results from the function. And that's related to what the job is that the function is doing. So you want to be clear on how the results will be used by the calling program. You want to answer these questions and think about that flow of control and that flow of data before you actually write any functions. And that will save you a lot of time and a lot of trouble later on as you're writing code and trying to get the program to work.